Hey all. So I saw this analog read serial, and it occurred to me after looking at the example that you could probably replace the potentiometer with a reed switch, and then you have a reed switch triggering your Arduino. So the first thing I wanted to do was just get this example circuit running, and it's a really straightforward circuit. So here's the picture. You got the potentiometer, one end going to ground, the other end going to 5 volts, and then this other line going there. I forget what they call it, but that's where it reads the value. And then here's also just the schematic of it, and then they give you the code. So I put the code in, and I have the thing set up, and I'll show you what that does. So here's that circuit, but the only difference is this is 100K pot instead of a 10K pot, but you have one end here going to 5, the other end got a alligator clip there going to ground, and then your sensor line is going to here. And so let's compile it. It's got to plug in before I compile it. And let's switch to the monitor. Give me a second. Control Shift M. And there's the thing going. Now I'm going to change the pot. Let me see, it's doing what it's supposed to. Now I'll change it the other way and take it all the way to 0. So that's kind of neat. So now the next thing will be to try to replace this part with a reed switch, and see when I pass a magnet past the reed if I can get a consistent change in the value. So give me a little while. Okay, so far so good. So what I've done now is I've gotten rid of the pot, and I've just put in a little voltage divider with, these are two 1K ohm resistors, and so you got again the negative, the 5 volt, and then the sensor line like it was before with the pot. And you can see it's doing that. The only difference here is I've got this set up here, so when this goes, it'll close. So I'm going to bring a magnet close. Take it away. So I like that. You can kind of hear the reed there too. Now the next thing is to try and do something with it. So you can see if we look at their code there, and again I haven't done this yet, so we'll see how it goes. But you see there's the sensor value, so that's the variable. So what I'm going to do next is I'm going to put in an if statement, and it says if this sensor value is, you saw I was going from 550 to 0, so like if sensor value less than 100, then turn on an LED for say 1/10 of a second, and that gets us halfway there. There's one more part to it that I've been thinking about. That'll be the last part. Okay, so now I just kind of took some of the code from Blink and put it in here. So define pin 13, it's output, and then what I'm saying here is if the sensor value, because you saw I was going between 500 and 0, goes to 0 when the magnet hits the reed. So if sensor value less than 100, then turn the LED on for a second, and then turn it off for a second. So here we have this, and we'll bring the magnet in. There we go. Okay, so now that's working. These magnets are too strong. But that's working, so that's very good. So of course, this doesn't have to be an LED. That can be your trigger to trigger a transistor or a MOSFET or an SSR to pulse a coil from a power source. So it's almost there, but it's not there because I've sped it up a little. My fingers are in the way. And you get the problem there is, like, let's say you're trying to do a millisecond pulse, and this reed switch is on for 5 milliseconds. Then that means you're going to pulse the coil. Did I wreck it? I probably wrecked it. That means you're going to pulse the coil 5 times all the time that the reed switch is on. So in other words, all it knows now is when the reed switch is on, pulse. But you want to be able to not, you want to be able to pulse it, say, 10 times faster than the reed switch and not have it pulse 10 times. So this is the part I'm thinking about, and what I've come up with is you have a second variable. Let's just call it J, and we're going to have if sensor value less than 100 and J equals 1, then you do a pulse, you shut it off, and then right here you go J equals 0. I don't know if this is going to work. I think so, but I'm not sure. And then when you come out of the loop and you go back up here, then you would set J equal to 1. We can get rid of all this stuff now. I don't care about the serial print anymore. But you kind of get the idea. You need one more toggle there to say only pulse once. So let me see if I come up with something that works. Okay, it took some diddling, but I did get it. So you need another variable, and so what I did here is I said integer J equals 0, and then we go down here, and so we say if sensor value is less than 100. So remember, it's normally sitting at 500. When the reed switch trips, it goes to 0. So this is when the magnet comes in. And if J is equal to 0, we set it equal to 0. Then you say LED high, LED low, and you set J equal to 1. So now it's no longer, this is no longer going to go. And then when it comes out of there, so it'll go once and then this will be 1. When it comes out of there, you say if the sensor value is greater than 300, because it's going between 0 and 500, so if it's greater than 300, it's going to be at 500. That's when the magnet's moved away. Then reset J to 0, and you can do this over again. So if I can show this to you, and it can sit there and sit there and sit there. It's not going again. Now I pull it away. Boom. So that's just what you want, or at least I think so. So what that means now, potentially, is you can have the reed switch, a reed switch motor. The reed switch will make a connection, and all that connection is going to do is say, all right, now you can time a pulse, and the pulse can be whatever you want it to be. Now the thing that I'm not certain on this So I think, the last part that I'm wondering about on this is the baud rate for reading this. But supposedly the baud rate, from what I've been reading, here it's set at 9600, and supposedly it can go up to 250,000, and I think that's like bits per second or whatever. But if you go to 250,000, that would be like I think 4 microseconds. So that's plenty fast. That's a lot better than you're going to do like just with a reed switch. and it's faster than the solid state relays that I'm using. But I hope that the baud rate doesn't become a problem. So in other words, this works, but when you actually get to pulsing the coils, is it actually going to be fast, or is it not going to be able to read this quick enough? But hopefully, I mean, again, if it really goes to 250,000, that's plenty fast. And even at 9,600, that's 100 microseconds. I mean, 10,000, 1,000 would be a millisecond, so 10,000 would be 100 microseconds. Which that's, I'm using the SSRs. They generally go down to maybe 20 microseconds. So we'll have to see. Now, the other thing I really like about this is it should give like a really clean test bed kind of thing when you start spinning a rotor, because normally when you're spinning the rotor, the on time and the off time are dependent on how quickly the rotor's spinning past your reed switch, or it doesn't matter if you're using a trigger wire or the other one. It varies depending on the rotational speed. But here, you could be rotating at 5 revolutions per second, or at 500 revolutions per second, and the pulse is going to be the exact same. So that could be kind of neat. So there's stuff that can be done with this, I'm pretty sure, and I'm looking forward to it. Thanks.